Hi Aslam class, welcome to your maths video on the 19th of January 2001. First thing we're going to do is do your arithmetic for today. So I'm going to go out to the screen and share my screen with you so you can see your arithmetic. Okay, so there are your questions. You've got 9 times 8. Which integer represents the 10th in that number? What is 248 as a Roman numeral? What is the next number in the sequence? What's 7 times 6? What's 54 divided by 9? What's 10% of 860? What's 4,353? Take away 2,110. Can you put these numbers in descending order? And then 44 divided by 4. You can pause the video now and get these questions down. Please don't spend more than about, well, 10 minutes, one question per, 1 minute per question. Okay, well done for doing that. Hopefully you've got your answers. I'm going to go through them very quickly with you on the board. So, question number 1, you should have got 56. Question 2, the integer that represents the 10th is the number 2 in that number. Roman numerals, so we've got 200, so 2 C's. Now 40 is 10 before 50, so we put 10 before 50, and that represents 40. And then we have 8, we have 5, add on 3, so V3 equals 8. So that's what you should have, CC, XL, V, I. Question 4, the next number in the sequence was 25, and in question 5, the answer is 42. Question 6, the answer is 6. For question 7, the answer is 86. For question 8, it's 2,243. Question 9, descending order, numbers start, descending means you go down. So you start with the top highest number and work your way down. So you should have 9, 6, 5, 3, and 1. And then the last question is 11. So well done for answering all those questions. Hopefully you got all of them right, but don't worry if you didn't get them all right. Try to do better next time. Right, today we are looking at solving correspondence problems. Correspondence problems are when you have sort of two. It's a bit like algebra, really. It's when you have sort of two values that sort of work together to help you answer a question. And it's about finding combinations of answers. It will come clear as we go through the video. But first of all, here's a 2-minute challenge. Using only these digit cards and a maximum of 2 multiplication symbols, how many different totals can you make? So you can only use multiplication and you can only use these digit cards. It says you can use a maximum of 2 multiplication symbols. So you can, if you wanted to, just use 1 for these. But away you go, 2-minute challenge. So for example, I could do 5 times 2. I could do 3 times 2. Or I could do 2 times 3 times 5. Yeah, so 2 minutes, off you go. Okay, well done. We're now moving on to our correspondence problems. And here is a definition, as you can see here on the screen. A correspondence problems are where a certain amount of objects are connected to another amount. So have a look at this problem down here. In this problem, we have 2 types of bread, okay? So that's one certain amount of objects, and they're connected to the fillings, and that's the other amount of objects, okay? So we've got bread and we've got fillings. So we have 2 types of bread connected to 3 types of filling. And then the goal is to find out all the different possibilities that you could have when making these sandwiches. So we're going to go through this problem. This question quite slowly so that you can follow along, and then I'll set you questions to do as well. So a canteen has 2 types of bread and a choice of 3 fillings. The bread we have is white and brown, and the fillings we have are cheese, tuna, and chicken. Number 1, list the different sandwiches that can be made. So for this question, it can be quite tricky. What I'm going to do here, I'm going to write white and I'm going to write brown. These are my breads. And then I'm going to write the different fillings that you can have. So here, cheese on white has already been done. What you can do, in fact, it might get a bit messy, but to help you out, you could actually do cheese, we could do tuna, and we can do chicken. And what we do, we think, right, how many different combinations can we have on white bread? We have 1, 2, 3. Okay, so with white bread, we can have white bread with cheese, we can have white bread with tuna, or we can have white bread with chicken. And then we have a look at the brown. We could have brown with cheese, brown with tuna, and brown with chicken. So with each, what's happened to my screen there? Why has it gone off? There we are, that's better. So with each type of bread, we can have 3 fillings. So if we know what we can have on one type of bread, we can have the same on another type of bread. So what we could say is that our combination, for every one piece of bread, we can have 3 different types of filling. So in this case, if we had 4 different types of bread, they would all still only be able to have 3 different types of filling. In this case, we can say 1 times 3. So with white bread, we've got 3 different things. With brown bread, we've got 2 pieces of bread with 3 different fillings. So 2 times 3 is 6. So there would be then 6 combinations that we can have. So the fillings that you should be able to get down for this one are white, cheese on white, tuna on white, chicken on white, and then cheese on brown, tuna on brown, and chicken on brown. This is a correspondence problem. Then let's move over to question B, which I've already kind of hit on. Complete the multiplication to represent the number of different combinations of bread and filling. So we know with one type of bread, we get 3 fillings. For 2 types of bread, okay, we're going to get a total combination of 6, aren't we? Because the white bread here has got 3. We've now got another set of brown bread. Okay, we're now going to have another 3 fillings. So that in total will be 6. Okay, if we had, I don't know, French bread, okay, with these fillings, we would then have 9 different combinations. So the times tables combination that we're going to write down here, okay, we've got 2 types of bread multiplied by 3 different types of filling. So we get a total of 6 combinations. Okay, how many combinations would there be if there were 4 choices of a sandwich filling? So now this changes it a little bit. Let's imagine that we now have a fourth thing, and let's say it's ham. Okay, now we can see that white has an extra 1, okay, and brown has an extra 1. For white bread, we have, for every slice of bread, we now have 4 fillings. So if we have 2 types of bread and 4 fillings, we multiply 2 by 4. So now there would be a total of 8 combinations. Hopefully you understand that, okay? It is a little bit tricky, okay? And here, what I've done here, this is actually something called ratio. So what this says is that for 1 piece of bread, you've got 4 fillings. So if I had 2 pieces of bread, I'm going to have a choice still of 4 fillings, but the combinations would be 8 because I do 2 times 4. Right? If I had 6 different types of bread here, okay, with 4 fillings, the combination would be 24 because each bread has 4 fillings. Okay, and if you've got 6 of them, you do 6 times 4. All right, hopefully that helps. So let's go to the next slide. And we're going to go through this one again. I'm going to go through this one again with you to make sure that you fully understand what you need to do. So, the pizzeria offers a choice of bases and toppings. And the choices that we have are deep pan and thin for base. And for toppings, we have mushroom, chicken, onion, peppers, and sweet corn. And the question asks us, complete the multiplication to work out how many different combinations of pizza there are. So let's do the first one first. Let's look at deep pan, okay? Deep pan, we're gonna have mushroom, chicken, onion, peppers, and sweet corn. So we have 5 toppings that we can choose from in total, okay? That's 5 toppings, okay? For deep pan. So for deep pan, we've got one base, we have 5 different toppings, okay? Now, let's include thin base into that now. So now we've got 2 bases. How many fillings have we got to choose from? We've still got 5, that's right. Okay, now let's work out the combinations, okay? Because we've got 2 bases and we've got a choice of 5 fillings, toppings, in total, we need to do 2 multiplied by 5, and that will give us 10. And that will give us the 10 combinations that we can make with these bases and these toppings, right? So think of it like that. Deep pan, 1, 5 toppings. We've got 2 bases. We've still got a choice of 5 toppings. To find out the total combinations, you multiply the 2 numbers together and you'll get 10. You can, if you want to, join lines together like that as well, if it helps you out. But that is the, and that's it. So hopefully that's clear. So what are you going to do now? This is going to be a little bit different to how our videos have been in recent weeks. So it's now going to be your turn to complete the questions. And what you're going to do, I'm going to go through the slides and you're going to pause at each slide, the video, so you can answer the question and then move on to the next one. Of course, if you're finding the first question really difficult and if you're spending quite a lot of time on it, then maybe don't go on to the next slide. Just do what you can. Please don't spend more than an hour in answering these questions, okay? And once I've gone through all the slides, I'm going to go back and go through the answers with you so that you can mark your work and then put it up onto Tapestry. So remember, I'm going to go through the slides. So here's your first question. Mo visits the fun fair. He buys a ticket that allows him to choose 1 ride and 1 game at the fair. Mo says there are 8 different possible choices of rides and games. Is he correct? And then explain your answer. B, then list all the different choices Mo can make. And then write in total how many he can make. So pause the video now and answer the questions. Okay, good, well done. Here's your next question. Aisha has 3 headbands and 5 hair slides. Kim has 2 headbands and 6 hair slides. Who has more choices of combinations for wearing 1 headband and 1 slide? Write down who has more choices. If you haven't got a partner to talk to, use a mirror and talk to yourself. Pause the video and good luck. Okay, this is your third question. So here are activity choices available at summer camp. Each child is allowed to choose 3 activities per day, 1 sport, 1 arts and crafts, and 1 outward bound. How many different activity combinations are there? Okay, and then B, due to a flooded pitch, football is cancelled. How many combinations are possible now? So this one's a pretty tough one, okay? So this is a real good challenge. And then we've got 1 more, okay? But pause the video, and if you've got time, you can do the next one. So Tom and Esther are building a snowman. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves to dress their snowman. How many different combinations are possible? And then write down the combinations. Okay, so that is the end of the questions. So you can pause, if you paused at each slide, and give you a bit of time to answer them questions. Again, if you haven't got through all of them, please don't worry. I'm now going to go back to the first question and we're going to go through the answer. So I'm going to make myself just a bit bigger here so you can see what I'm doing on the board behind me. So Mo buys a ticket that allows him to choose 1 ride and 1 game at a fair. He says that there are 8 possible choices. Is he correct? So we need to find out whether he's correct or not. Let's have a look at the rides. We've got the Big Dipper, we've got the Dodgems, and we've got the Carousel. So we have a total of 3 rides. Okay. The games, we've got Hook a Duck, Basketball, Coconut Shy, Lucky Dip, and Test Your Strength. So we have 5. Okay. We have, and he can only do 1 ride and 1 game. So if we have a look at that, okay, he can go on 1 ride and he can go on 1 game. He's got a choice of 5 games. Okay. So let's take Big Dipper. If he was on the Big Dipper, that would be his ride. He could then choose 1 other game to play, okay? And he's got a choice of 5 there. So there would be 5 combinations if we used a Big Dipper, okay? But in our question, we have 3 rides, okay? So we multiply 5 by 3. And that gives us 15. So we now have 15 combinations that he could use. So is Mo correct? No, he's not. He's incorrect because there are 15. And in your explanation, you just need to show that 3 times 5 is equal to 15. All right. So well done if you got that one correct. Okay. And it says here that Mo can make 15 different choices. And when you list all the different choices, it's Big Dipper, Hook a Duck, Basketball, Coconut Shy, Lucky Dip, Test Your Strength. It's then Dodgems, Hook a Duck, Basketball, Coconut Shy, Lucky Dip, Test Your Strength. And then the last set is Carousel, Hook a Duck, Basketball, Coconut Shy, Lucky Dip, Test Your Strength. So we can make a total of 15. Well done, if you got that one correct. Okay, our next question is Aisha has 3 headbands and 5 slides and hair slides. Kim has 2 headbands and 6 hair slides. Who has more choices of combination for wearing 1 headband and 1 slide? So let's have a look at Aisha first. Okay, Aisha has 3 headbands and 5 hair slides. Okay, and if she was to use that combination, so let's do her headbands and then her slides over here. Okay, she's got 3, haven't she? She's got 1, 2, 3 choices, 1, 2, 3, 4, 5 choices of slides. So what we're doing here, we're effectively doing 3 times 5, aren't we? Because we've got this combination happens 5 times, okay? We've got 3 of these combinations that could work, because if we did 2 going to every single one and 3 going to every one, when you count up the lines, you get 15. To make it easier, let's just have a look at the ratio that we've got. She's got 3 headbands and 5 slides, so 3 times 5 is equal to 15. Kim has 2 headbands and 6 hair slides. So Kim is 2 to 6. So 2 times 6 is equal to 12. Who has more choices? Aisha does. She's got 15 choices where Kim only has 12. Well done if you got that question right. On to the next one. Okay, this one is a little bit trickier because not only do we have 2 groups, we've actually got a 3rd group as well. So the activities are available at summer camp. Each child is allowed to choose 3 activities per day. 1 has to be sport, 1 has to be arts and craft, and 1 has to be outward bound. So if you were to draw this one out, you would have lines going all over the place. Okay. So as you can see, we've got 3 groups here, okay? And we've got to choose 1 from each one. If we started doing lines all over our page, it would get so confusing, we wouldn't be able to do it. So let's have a look. Sport, we've got a choice of 3 different sports. Arts and craft, we've got a choice of 4. For outward bound, we've got a choice of 3, okay? Now you only have to pick you're only allowed to pick 1 of each at a time. Okay, so our combination is going to, let's say football, for example, it'd be football, painting, wall climbing. We could then have football, painting, kayaking. We could then have football, painting, and abseiling. Okay, So football, painting, and wall climbing, football, painting, and kayaking, football, that's 3 different combinations you could have. You could then have football, pottery, wall climbing, football, pottery, kayaking, football, pottery, abseiling. That's another group, so that's 2, okay? So what we're doing here is exactly the same. We've just got another group. And it can get pretty complicated by saying it out like that all the time, but there's a quick way of doing it. Why don't we just do 3 times 4, okay, for our first group. So football to arts and craft. There would be 12 combinations there, wouldn't there? We've now got another group, so we've got another 3 combinations that we could use. Okay, so all we're doing is multiplying all 3 numbers together, aren't we? And that is what we've done last week or a couple of weeks ago. So 3 times 4 is 12, times the number 3 is 36. So there are 36 different combinations that you could use. Question B says the football pitches are now flooded. So how many combinations are there now? So now we've only got 2 sports, still got 4 arts and craft and 3 outward bound. 2 times 4 is 8, multiplied by 3 is 24. So now we only have 24 combinations because football has been taken out. I hope that's clear. Okay, and for the last question, well done if you got this far. I know these questions can be quite tricky, but Tom and Esther are building a snowman. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves. How many different combinations are possible? You're multiplying all 3 numbers together. So 5 times 4 is 20, times 2 is 40. So there are 40 possibilities. Okay, that's your maths lesson done. I know them questions were probably going to be quite tricky for you, okay, but hopefully you've got a good idea of what they are. If not, remember to bring this up in the live Teams meeting that we have on Wednesday at 10 o'clock. Please make sure that you're also using Table Rockstars. I put a challenge up on there for you guys, so I will be checking that as well. So please make sure you get onto Table Rockstar as well. Don't know your password or username, please email the Year 4 teachers at langleyacademyprimary.org and we will get back to you as soon as we can on that one. Right, good luck. See you in the next video.